morning, we are Team 3. My name is Julian Duarte, and the problem statement we are focusing on is students need a way to learn about sound, waves as a vibration in a way that is engaging, hands-on, and visually clear, so they can actually see the movement of the sound and record the data from their observations. Right now, students often learn about sound waves through diagrams or lectures, but they rarely get to see how sound physically moves through a medium. Our goal is to design a device that turns sound, which is normally invisible, into something students can observe. To guide the design, our group created several criteria. The device must be lightweight, easy to assemble and disassemble, safe for both students and teachers, and simple to operate. It also needs to allow students to record data, whether that's through movements, visually, or tracking vibration patterns. Ultimately, the device should help students connect what they see and hear in a way that is understandable and measurable.
All right, hi, my name is Johnny. I was responsible for making a CAD design for our Chladni plate project. So starting at the base of the box, it will act as a storage for the sound system, cables, and controls. It also has a large footprint, so it can catch the excess sand that falls off, so it'll prevent a mess. In the middle of the Chladni plate, that's where the subwoofer will be mounted. The subwoofer will have a bracket attached to it with a metal rod that extends upwards, and that connects to the plate itself. We chose aluminum for the plate because of how efficiently it transmits vibrations. When the vibrations go up through the rod into the plate will vibrate, and the sand on the plate will move, and the sand will create visible patterns that change in response to the frequency that's played through the subwoofer. The overall goal of this design is to demonstrate how frequencies influence and organize particles, creating dynamic and unique patterns in the sand.
Hi, my name is Mo Sharaf. I was in charge of working on our second model. This model explains how we can understand and predict the frequency of a pattern. With this information, we can use it to find the wavelength of the plate, and it allows us to create a list of resonant frequencies, and it eliminates the need to test every frequency. Following this, our 5 criterias for this design were interactivity, the visuals, vibrations, the design of the container, and how easily we can move this product around. Our solution satisfies our problem statement and criteria because we are able to explain to students the vibrations that come from sounds with our design. This device provides an engaging and visual method for students to learn about sound waves as vibrations. This is achieved by using a speaker to vibrate a plate, causing the sand to arrange into visible geometric patterns. Furthermore, this design is interactive because our students can change the input frequencies using a smartphone.
My name is Brendan. Our model is an improvement on the most common existing models to explain how vibrations travel through objects because it is far more visual than the others. The most common currently used model is attaching 2 megaphones to a string, putting the students in different rooms and having them talk to each other to explore how vibrations can travel through the string. Our model is an improvement because it creates shapes by using those vibrations in a much more engaging and fun way because the students get to see the interactions between frequency and shapes that are made.